I'll remember that we went over something similar in our group meeting, and I'll go back and I'll rewatch like how you explained it and stuff. So I actually use these videos for reference.
That actually makes me very happy to hear.
And it's helped quite a bit actually. So yeah, I like having these meetings recorded. But all right, so
And then you're like, ah, F. You're like, why do we spend an hour talking about movies? Now I have to freaking filter out of that.
it's so great. It's so great.
It must be fun trying to find what you're looking for when we just take so many tangents.
It's kind of funny actually going back because I don't really realize it when we're like talking, but like going back and I'm trying to like get an answer, like it's funny. It is funny.
You're like going through and you're like about to get the answer, and
But
suddenly cat pops up, and you're like, oh, cat, dang it. And then it takes
so
15
cute.
minutes for the cat to go away.
And then we talk about cats and how cute they are, and then we talk about it's great. It's great.
Well, I'm glad that that's been useful for you. I didn't realize that you've been doing that.
Yeah, no, I've done it not every single time, but yeah, no, I've definitely done it. So
Yeah. No,
but
it sounds time consuming. So it sounds like it's one of those things that if the book just isn't making sense, that then you would dig into it. But I'm really glad because I wouldn't have thought of that resource.
yeah. I mean, you explain it way better than the textbook will ever explain it. So,
Well,
but
thank you. Because I'm going over fifth grade math with a fifth grader now, and oh my gosh, it's fun, so much fun. The
so
kid,
much
the
fun.
kid's great. I absolutely love him, and
Yeah.
he's a smart kid. It's just that we're going over just things like literally just like fractions and division, including decimal points and stuff. Like, and so sometimes like I'll mention something, and he just kind of gives me a blank stare. Because like today we're going over story problems,
Yeah.
and so like it was just something simple of it was like Corey has 42 pounds of clay, and he wants to separate them into 7-pound clumps. How many clumps will he have? And so we go through it, and he understands the math just fine. Like his mom's just
Mhm.
having me review it with him 3 times a week so that he doesn't lose any ground over summer.
Yeah.
But yeah, so like we're going through it, and then he's like writes down the answer, and it's the right answer. I'm like, good. Now what are you forgetting? And he looks at me for a second, and it's kind of just a look that goes back and forth. I'm like, you forgot to put down the units. And he looks at me and he's like, what's a unit? I'm like, oh, you're not going to bother with the units until like seventh or eighth grade, and you're in chemistry or physics or something. So we had to go
Yeah.
into what units are and stuff. I'm like, you totally had the right answer. It's just that you needed to put like you needed to put 8.2 whatever, whatever it was. Like you need to put 8.2 lumps of clay. And he's like,
Yeah.
8.2 lumps of clay? He's like, that's so stupid though. Why would I be writing lumps of clay in a math problem? And I'm like, I promise you, it will make more sense if you once you get into physics and chemistry, but you just need to start learning to write down units at this point.
True.
that
Well, I had teachers they
that
would
was
mark
a
it
that was a
wrong.
tough sell, man.
Yeah. Well, I mean, teachers will mark it wrong even if you don't put the unit. So it's smart that you're getting him to do that early. So
Which they should, but yeah, no, it was just kind of like it was a tough sell because I remember when I was his grade because I remember specifically. So he's just out of fifth grade. I remember when I was in fifth grade, I had a student teacher who, at the end of the day, we would have to write down something that we learned in class, and if it was really good, then she'd put it up on the board so like everyone could be like, "Oh, you're so creative, Ryan! Way to be smart." And I only ever got one of my notes put up once, and it was
oh,
about division with remainders. So I was asking him, I'm like, okay, so when you do division, do you do remainders or decimal points? He's like remainders, and then immediately thought back to that. I'm like, oh yeah, I wrote a sentence about remainders. I'm like, this is fifth grade, and so like, yeah, so like some things like click with me, but then yeah, I remember like in fifth grade, I remember my teacher, that same student teacher would ask something dumb like, you go to the zoo I mean, like you go to the circus and the circus has 17 elephants, and then they have to, and then two of the elephants give birth, and now there's 19 of them. And so I would obviously 17 plus 2, 19. And she'd mark it wrong because I didn't write elephants. I'm like, of course it's elephants. There's nothing else we're dealing with here.
Come
And now
on!
I'm having that same fight with a fifth grader like 20 years later. I'm like,
Hilarious.
I'm like, no, you have the right number. You just have to write lumps of clay. It's like, why would I write lumps of clay? I'm like, just trust me, it'll be worth it.
That's hilarious. Oh man.
What my
It will be worth it.
Okay, so question 1. I participated, yes. Okay.
Yay. Right.
Article in the Journal of Small Business Management successfully startup. Okay. So honestly, looking at question 2,
Mhm.
it's pretty much all a red herring except for one word. What's the keyword we're looking for?
Wait.
Because the answers we're given are the type of analysis. So one sample Z, one sample T, paired T, independent T, ANOVA, so all that kind of stuff. They could literally give us one word from this paragraph and it would let us know what type of analysis we'd want to do.
Um, Independent.
Exactly. So if we're wondering if something is independent from another thing, what type of analysis are we going to do?
Independent sample t-test.
Why? Okay, let me rephrase that. What does an independent sample t-test do for us? What
um,
what does it compare?
it compares the means
The means of what?
of like independent groups
So it compares the means of two groups.
that are not related.
Yes. And so we're looking at the means of two groups, and basically we're looking at our null hypothesis is that they are going to be equal to each other or that there is no difference between them, just like the chevron gas. And then the alternate hypothesis is that one of the groups will be different than from the other, either be a two-tailed test greater than or lower than. So that tells us that they're different from each other. This question is asking, is the level of managers of successful startup companies, so is the education level independent of the country they're from? So we're looking for not are they different or are they the same? Were you going to use a confidence interval or a p-value to determine that to a certain confidence? This is asking, are the two variables, education level and country, independent? Which is another way of saying, does one affect the other? And
Yeah.
when we're wanting to check to see if something affects another thing. So, for example, um, eating good nutrition, so the number of apples you eat versus your height in adult life. When we're comparing those types of things, and we want to see how connected they are, so whether they are independent or not independent. Do you remember what test we use?
Um, if we're comparing the two,
We're not comparing the two directly. So we've got two variables that we're looking at.
mhm.
We're looking at the education level. So the education level of managers who successfully created startup companies.
Mhm.
So we're looking at their education level, and then we're also looking at their location, either United States or Korea.
Mhm.
We want to see, obviously, there's nothing you can compare between those two. Education level is categorical. Did you do high school, college, master's, doctorate, further study? The other one is categorical, United States or Korea. So they're two categorical things that we can't directly compare. So instead, what we're looking for is we're seeing, does one affect the other? Does being in America mean that you're more likely to have a master's degree? Does being in Korea mean you're more likely to get a PhD? Or the inverse, which would be weird. Does having a doctorate make you more inclined to live in Korea?
So would it be
So,
test of two proportions?
no, we're not looking. Well, proportions, we're still comparing two things directly. This
Mhm.
is this is indirectly comparing two variables to see if they're connected, to see if they're independent or not independent.
Hmm. Um, would it be a nova since it's like since there's so many like high school, undergraduate, masters?
I see where you're coming from. If they were asking the question differently,
Mm-hmm.
you could do ANOVA based on that.
Mm-hmm.
You could do proportion based on if. So let's say the question was just um, there is a the people who successfully startup companies in America versus Korea. The null hypothesis is that there's no difference. We want to see if people in Korea, due to lower state I can't think of the word, legislation, restrictions, laws, regulations. There we go. So the null hypothesis is that they're the same. We want to know, is the percentage of people who try to create their own company higher in Korea due to lower regulations? That would be a test of two proportions. You'd look at the people who tried to create a company over you'd look at the people who did create a company over all the people who tried.
Mm-hmm.
So the ones who made it over the total would give you a proportion, and we have America and Korea. So in that case, you actually could see a test of two proportions. But they're
Yeah.
not asking, are the proportions different? They're asking, is there a link? Is there a link between education and location?
So would it be uh okay, so it's not proportions, it's not ANOVA, it's not paired because one doesn't determine the other. So it has, but one's, isn't this more than one sample?
It's definitely more than one sample. We're
Because they're
taking,
taking one from the United States and one from Korea. So the only thing left is a chi-square, or it's, is it
yeah, Kai.
chi-squared test of independence?
Yes, and that's right there. It's there in the name. Test
Yeah.
of independence. We're looking to see if the level of education and the location of the company are dependent, or as they say, you want to determine if the education levels and the education levels and the location of the companies are independent. And so that's what the chi-square does, is it tells us how dependent they are.
Oh, the chi-squared one does?
Yes. And do you remember the discussion we had last time about correlation and causation? That things may be
Yes.
tied together, but that doesn't mean one causes the other.
Yes.
That's what chi-square tests. So they want to see if there's a pattern between successful startups um, and location.
Okay, so it would be the chi-squared test of independence.
Exactly. Yeah, they're not saying like a paired sample would be kind of hard to do. So, for example, if we're doing that, kind of let's just go through these. A paired sample test would be um, we have a bunch of businessmen who tried to start up companies in America and in Korea. And then we
Mm-hmm.
compared how successful they were with creating companies in both places. Since we're dealing with that same business, since we're dealing with a group of
Mm-hmm.
businessmen who were both in America and Korea, then that would be paired samples. If we
Okay.
were just looking at, um, if we were just looking at the number of successful businesses in Korea versus the number of successful businesses in America, and there was no connection between the sample, so the
Mm-hmm.
people who are creating those businesses, that would be an independent sample t-test, like you're talking about.
Mm-hmm.
We were looking at something different that required a lot of categories, like how successful are people at creating their own businesses when they only have a high school education, an undergraduate education, a master's, and a doctorate?
That'd
When
be
you have all those, that would be a NOVA.
okay.
And then if we were to do the test of one proportion, that would be we would look at just either one of the two. So either United States or Korea.
Mm-hmm.
We'd say currently the proportion of people who start up a company and that company remains open for more than 2 years
Mm-hmm.
is whatever. So that would be like 45, like 0.45 or something. What we would do is we would make an alternate hypothesis and say, we believe, so our null hypothesis is the proportion p hat is equal to 0.45. Our null hypothesis is then p hat is two-tailed, so not equal to, or one-tailed, less than or greater than 0.45. So that's how we do one proportion with this. If it was two proportions, they would give us the proportions of successful business creators in Korea and America, and then we could test those together to see if they are significantly different at all, or if um, the economic landscape of Korea and the United States are essentially similar. But this one, they don't care about comparing those two things directly, the United States and Korea. They're actually comparing the stats of education and United States indirectly, seeing if there is any correlation, if there's any dependence between those two. Does being in America make you more prone to getting a master's degree? Does being in Korea make you more prone to getting a PhD? Does having a PhD make you more prone to move to Korea? Does having a PhD make you more prone to moving to America?
Mm-hmm.
They're looking for a correlation there. And that's why we're using a chi-squared here.
Okay.
Does that make sense?
Yes.
Okay. Because
Hopefully.
if you remember, the chi-squared was so heavy with math that the we just did the work, like we just did the Excel, and it
Mm-hmm.
didn't even really give us too much good information. Like the other times when we're given good information, we're like, oh, this is, you know, we got a p-value of 0.03, so that means it's above our alpha, it's below our alpha, which means that we're confident to say that this is the case. Chi-squared is a little bit different because it's like chi-squared, you get a p-value, but that p-value doesn't necessarily tell you we are this confident of this answer. Instead, it talks about this is how interconnected the two things are. So the higher you turn the volume knob, the higher you turn up your volume knob on your TV, the louder your TV gets. That's
Mm-hmm.
going to be a one-to-one correlation. So the louder you turn the knob, the louder your TV gets. Straight up correlation, just a one-to-one correlation.
Yeah.
You have um, something like the number of children swimming in the community pool versus the number of penguins in the Arctic. There's no correlation there, you
Yeah.
know? So chi-squared tries to show us if there's a correlation and how strong that correlation is. Because sometimes you get something that is correlated, but not one to one. Like,
Yeah.
for example, did I tell you about the identical twins in that I graduated high school with?
I don't. Maybe.
Well, long story short, I graduated with identical twins, and they are identical. Like, I went to school from middle school into high school, and I still couldn't tell them apart.
That's
Until
insane.
after we graduated, because I have no idea why, but one of them shot up to like 6'3".
Oh,
And
okay.
so one of them is like 5'10", 5'11", and the other is 6'4". And the thing is, we know that nutrition plays a role in how tall you get. The more the more nutrients you're getting, the better your body is at growing. We also know that genetics play a role. The fact is, you simply need the genes to be tall.
Hmm.
So we know that nutrition, we know that genetics play roles in height, but it's not a one-to-one correlation. Because if it was a one-to-one correlation, these guys would be exactly the same height because they have the exact same genes, you
Yeah.
know. So that's what the chi-squared does is we're looking for a correlation, we're looking for a relationship. And it lets us know if there's a correlation. It's very rare that it's going to tell us that there's a one-to-one because
Hmm.
it's very rare for there to be a one-to-one relationship between anything. Like I
Yeah.
said, like the times that you're getting a one-to-one relationship are the things that you don't need to study. Like I turned the volume up on my computer, the volume went up. That's obvious.
Yeah.
I walked 60 feet away from my home. I am now 60 feet away from my home.
Yeah.
You don't need to study those things. So the
Uh-huh.
chi-square show us is to kind of help us. Is there a connection between these two? Like, obviously, there's going to be some disrupting factors, so we're not going to see a one-to-one relationship. But we've been noticing some patterns, so we would like to establish: is there any connection here? If I end up using crop rotation, so I don't plant the same crops in the same fields over and over, if I
Yeah.
actually rotate what I grow in what areas, is that actually going to increase my yield? And you could use this to kind of show, yes, there is a correlation. If you end up rotating your crops, then there is a slight yield, and there's going to be other things that play into effect, obviously, like weather. If you have a drought, your crops are going to be worse.
Hmm.
But holding for the other variables, crop rotations generally give better crop yields. And
Yeah.
that's what a chi-square does, is it tries to see if there's a connection between two variables.
Okay. Yep. Highlight that. Okay. Cool.
And like all stats, it can be tricky. Like I told you, um, after an inconvenient truth came out, a stats professor at BYU used chi-square to show that there was a connection, that the number of pirates in the world going down, global warming going up, and he couldn't say that they're dependent because he was a stats professor, but he was able to show mathematically that they were not independent. So there was a connection between them. And the
Yeah.
fact is, the connection is probably just technology. The
Mhm.
fact is, technology goes up, we end up using more energy, greenhouse gases, whatever. And then with technology, there's more security, there's more surveillance, it's harder to commit crimes,
Mhm.
so pirates go down. So there's a
Yeah.
connection, but the connection isn't pirates fending off global warming.
Yeah.
The connection is a third variable that affects both of them.
Yeah.
So, and that's what chi-square does, is it only shows us if there's a connection. It doesn't tell us if one causes the other or not.
Yeah.
Okay,
Interesting.
ready for question 3?
Yes.
Okay, let me know when you got your answer.
Okay. Hmm.
What are you thinking?
Are they paired?
So we have two groups, 40 years and older
Because
or
it's like
younger than.
if you're not in that group, then you will for sure be in the other group. So they are, I feel like they're paired.
But let's put it this way.
Hmm.
If I were to tell you that Daryl Jensen was in the 40 years old or older group,
Hmm.
does that give you any indication of who may be in the 40-year younger group?
No.
What
Okay.
if we did it what if we did it this way? Which would be crazy if a company had this level, like had this hiring type stuff,
Hmm.
but it gets the point across. Let's say this company um, looks at people from families. And so they split this up into a group of 40 years old or younger and over 40. And for every person over 40, they also have someone related to them, either as a son, daughter, niece, nephew, that kind of stuff.
Hmm.
If I were to then tell you, does Daryl Johnson is in the 40 years or older group, could you distinguish a person from the younger group just by looking at names?
No.
Well, you would be able to. Like if you had a roster of the entire everybody who worked there
Hmm.
and you didn't know who was in what group, but you
Hmm.
heard that Daryl Johnson was in the older group,
Hmm.
then you could immediately go and you're like, oh, if Daryl Johnson is going to be in the 40 years and older group, then that means Cerise Johnson, his daughter, is going to be in the younger group.
Oh, okay,
So
okay.
that
Yeah,
would
yeah,
let you
yeah.
know right there.
Okay, yeah.
So if that was the case, then that would be paired.
Okay.
But because knowing who is in one group doesn't tell us anything about who's in the other group, this
Hmm.
is two sample independent.
Okay.
Because yeah, I remember you telling me when we were first going over this, the way you think about it is like siblings,
Sibling.
spouses. It's yeah, the key marker is if it's the same person doing it twice, you know. So if somebody is on before and after a diet, you just have the person before, then you have the person after the diet. That's super easy because it's the same person. That's paired. Otherwise, be looking for things like siblings, spouses, um, something that says that they're specifically. Sometimes they will get people who are very similar,
Hmm.
like height, age, weight, and then put them into the two different groups to mirror each other. And in that case, it would be paired. But look for something specifically stating that you're going to get some idea of who's going to be in group two by knowing who's in group one.
Okay. So would it be um it's not a one sample, it's two, right? So
Mm-hmm.
it would be independent sample t-test?
Exactly.
Okay. Okay. All right, four.
Okay, this one's a little trickier. I've got it narrowed down to two, but what are you thinking?
So it's definitely a proportion.
Yeah, definitely that.
Um, would it be two?
Why are you thinking two? Walk me through your thought process.
So I guess they narrowed it down to wanting to compare two different group. Well,
Are they comparing two groups? Yeah, that's what I fell into when I first read the question.
you're right. They're not. So I guess they're taking one sample. If you want to determine the proportion.
So here's one way you can figure out whether it's two proportions or a single proportion.
Mm-hmm.
Because with one proportion,
Mm-hmm.
there's going to be two variables that we're dealing with, and only two. We're going
Okay.
to be dealing with p and p hat. Do you
Okay.
remember what p and p hat refer to?
Uh, yeah.
So
It,
p, if mu is the population mean
uh-huh.
and x bar is the sample mean, then p is the population proportion, and then p hat is going to be the sample proportion.
Sample. Okay,
Does
yeah,
that
yeah.
ring a bell? So
Uh-huh.
we're looking at this problem, and we see that they surveyed 200. They surveyed 2,406 adults. From looking at that, they have. Let's see. So from that, what are they referring to these people as? This was a weirdly worded question.
Heavy players.
Yeah, but they give us a p, and the p is 48.5. So out of the 2,406, there's a proportion of 0.485 who is proportion of male heavy is different than the proportion of male. Okay. Oh, this is a weirdly worded thing. Let me. Now I need to parse this even more. This is weird.
And
So a total was classified. So total adults were surveyed, but we're specifically concerned about male.
it doesn't tell us
Um,
how many of the random sample were males. They only told us how many are heavy players
yeah.
that were male.
So a total of 248 were classified as heavy. So out of the 2,400, 248 were classified as heavy. Of those, a little more than half, 152, were male. If this was comparing male to female, then it sounds like it would be two proportions. But it looks like we're comparing male to, if you want to determine the proportion of male heavy lottery players is different from the proportion of males in the population. Oh, I see what it's saying now. Okay, that was dumb of me. Okay, so here's what we have. We surveyed a total of 2,406 adults, right?
Yeah.
48.5% of those adults are male.
Oh,
There was a smaller subset, 248, were classified as heavy players, or I guess you could say addicted to gambling.
yeah.
Of those addicted, 152 were male. You want to see if the proportion of males who are addicted to gambling is higher than the total than the is higher than just the number of males who gamble in the first place, which is
Okay.
40.5%.
Yeah.
So we're seeing okay, there's almost a 50-50 split between people who play the lottery, between men and women who play the lottery. It's not like it's totally dominated by females and it's only a female quote unquote sport.
Mhm.
Um, this is pretty evenly divided, almost 50-50 between males and females.
Yeah.
We have heavy players, those who are prone to addiction or are addicted at this point.
Mhm.
And those guys make up a group of 152 out of 248. So even though men and women are equally represented in gambling itself, are men overrepresented in addiction?
Yes.
So if that's the case, then that would be a test of one proportion, because all we're going to be doing is comparing p hat, our 152 over 248, to p, which is 0.485. So we don't have p hat 1 and 2, we just have p hat And since we don't have p hat 1, p hat 2, p hat difference, since we've only got p hat and
Uh-huh.
p, then that lets us know that we're dealing with just a test of one proportion.
That makes sense. Okay. Yeah, that makes a lot of sense, actually.
That was just a weirdly worded question with a lot of numbers in there.
Okay.
Okay. Question 5. Okay. So let me know when you got the answer for this one.
Paired sample t-test.
Okay. Walk me through your reasoning.
So I remember what you said earlier about kind of the thing to look for with paired is if the same person is doing the test twice. And so it says each student was given the combination to each lock. So the same student did it twice. So that's why I think it's paired.
Okay, perfect. Yeah. So
Okay.
we have 25 students. Each student is going to be doing 2 locks. So they're basically recording the time 50. They're recording 50 times,
Mm-hmm.
But yeah, exactly what you said, because one is using the clockwise and then they're going to be using the counterclockwise. It's the same student. So you can totally pair it up. So like I was saying, if your group 1 tells you anything about group 2, then you know it's paired. So if you see Devin Rexberg in group 1, you know Devin Rexberg is going to be in group 2 with the counterclockwise.
Yeah.
But you totally you hit the nail on the head with the way you explained it. So paired sample t-test.
Whoa.
Okay, for the next 3 questions, identify the one confidence interval that makes the most sense.
I remember them asking this question, or this same kind of um, the bank appraisers and stuff. Mm. Um, okay, so my initial reaction is do paired, but after a conversation about the last one that I thought was paired, I'm gonna say it will be independent samples.
Okay. I think I think I know what's going through your mind.
Mhm.
Walk me through the process.
So they have two appraisers and they want to know the difference. Um, and so, um, and it's definitely two samples because it's appraiser one and appraiser two. So that gets rid of the one sample answers. And then it's not paired because because they're not related.
Aren't they?
I know, because now I'm like, maybe they are.
Think of the question this way.
Hmm.
So it says the bank employs two appraisers.
So it's like,
So we have one appraiser showing up to a house, and then the second appraiser shows up to the house and does their thing.
yeah.
Think about it this way instead. What if instead of two appraisers, it was one appraiser who came to a house before and after a a bird pool had been installed, or just like a fountain feature.
Uh-huh.
And they're wondering, does a fountain feature increase the sale value of a house?
Hmm.
Even though the house is an inanimate object, it can still be a sample that can compare against itself.
Hmm.
So in
That
this
would be like
case,
a two sample t-test, maybe?
well, the houses that the appraisers are looking at are the same houses, right?
Yes.
So that means knowing that 1313 Mockingbird Lane is on the list for appraisal number one immediately tells you that 1313 Mockingbird Lane is on the appraisal list for appraiser number two.
Okay, so I was thinking more of the appraisers, not the houses.
Yeah, in this case, the appraisers are actually the experimental treatment,
Uh,
whereas the houses are the sample.
okay, so it would definitely be paired
Yes,
because
yeah,
they are doing the same houses. It's just two people, two different people. Okay. I was focused too much on the appraisers.
no problem.
Dang, I gotta remember. These trip me up a little bit, I'll be honest.
Yeah,
Okay.
you just got to think, does the first group tell you anything about who's going to be in the second group?
Yeah.
And the groups that they have is basically going to be pieces of paper that say an address and how much it's worth. And if you're to look at it, you see the address and you're like, okay, the address is on Jeff Baker's appraisals. And
Hmm.
then the other appraisal, like Jeff Baker, the other appraiser, John Baker, I don't know. But you see the address and you're like, okay, I know for a fact that this address is going to be on John Baker's list also. So
Yeah.
that's how you know that it's paired sample as opposed to independent sample.
Okay.
So does that make sense?
Yes.
Okay. Because yeah, I'm like 95% positive that you just overthought it and you thought the appraisers for some reason were the sample group, where the sample is
Yeah.
actually the houses.
Dang, I hope I don't get tripped up on this on the test. I'll just review this a lot. Okay, so let's do 7. Sweet.
Okay. Let me know when you've got your answer.
Okay. Um, Independent samples.
Why are you thinking independent samples?
So I'm doing the process of elimination. So there's two samples,
Hmm.
the accounting and the psychology majors. So the one samples are out. They're not paired because, um, yeah, they're just not paired. And then proportion, we're not given a p hat or a p. We're just giving, so that's why I think it's independent.
You know what's frustrating and crazy?
What?
It could be independent. It's the way that they worded and the way that they're running this test.
No.
So let's say, um, so it states article on satisfaction of career paths, the percentage of psychology majors reporting that they were satisfied. So we've got a percentage, which means that we know we're dealing with the proportion. If, on the other hand, they
Uh-huh.
asked psychology majors to report on a scale of 1 to 5 how satisfied they were,
Uh-huh.
then we'd be given a concrete number. And that concrete number we could use in an independent sample t-test. But because they said, are you satisfied or are you not, we're left with a percentage. So the people who are satisfied over the total people who are asked, and since we have a percentage rather than an actual concrete number, we
Mm-hmm.
have to go with proportions.
Huh.
You're looking
Well,
looking confused. Do you need me to explain that again, different way?
yeah. Yes, please.
Okay, no problem. Okay, so the main thing that we're looking at here, when we're
Mm-hmm.
looking at confidence interval, um, yeah, so like when we're comparing independent samples or paired samples, when we're comparing samples like that,
Mm-hmm.
we're looking mostly at, yeah, we're pretty much looking at not qualitative but quantitative data. We're looking at numbers, right?
Mm-hmm.
And those numbers tend to have units on them, like miles per gallon on gas or height in inches if we're looking at how tall people are and whatnot. If the study that they're doing was, we wanted to see how satisfied people were, how satisfied psychologists and accounting majors were in
Mm-hmm.
their career, they could say, let's do on a scale from 1 to 5, how satisfied are you? And then they get the report back. Psychology majors, there were so many psychology majors, like we'd have a sample of 450 psychology majors. Um, the average of their surveys was a 4.5 of satisfaction out of 5. And then we took another study of accounting majors, and we had 150 in that sample, and theirs was 4.8. Is there a difference between these two sample groups? And because we have actual numbers to compare them to, a 4.5 versus a 4.8, we could totally do an independent T sample. But because they're reporting the numbers not as numbers, but as a percentage, simply people who responded satisfied over total number of people asked, that's going to give you a percentage. And whenever we're dealing with percentages,
So,
then we're going to be dealing with proportions, whether it's a one sample proportion or a two sample proportion.
okay, I need to write that down.
Because that's the key, is that you're completely right. It's just that one word, it
Mm-hmm.
says in the second line, the percentage of psychology majors reporting they were satisfied. So we're looking at a percentage.
Yeah. Okay.
So that's the keyword. So for chi-squared, a keyword you're looking for is linked, independent, dependent. Those are the kind of things you're looking for chi-squared.
Mm-hmm.
For proportions, you're looking for either the word proportion, percentage, being presented a percentage. So like 95 and then the percentage symbol afterwards.
Mm-hmm.
95 wasn't good because that's our confidence interval.
Mm-hmm.
So you see that a lot anyway. But like 65%, or seeing a proportion 0.65.
Okay.
So look for the word percentage, look for the results being presented in either decimal form, like 0.65, or a percentage form, 65%. If you see those, then that lets us know that we're dealing with proportion, either one sample or two sample proportion.
Okay.
Otherwise, they're going to be giving you straight up numbers like I said, miles per gallon, inches, height in inches, um, miles per hour for how fast a car can go, that kind of stuff. So as
Yeah.
soon as you see percentage or results given in percentages, that should be kind of a that should be a flag, not a red flag, but just kind of a warning light that you're like, okay, we're dealing with proportions here.
Yeah. Okay. So this is definitely gonna be proportion, and it's gonna be a um two proportions. Two
That's what I'm
proportions.
saying. Because
Yes. Two proportions. Okay.
we're going to have p hat versus p hat 1 and p hat 2.
For
P hat
psychology
1,
and accounting.
exactly.
Okay.
If how would we make it a one sample?
If it was just psychology or
Yes.
just accounting.
Yeah. So if it was psychology and they're comparing psychology to, um, so if they're doing psychology versus everybody in all fields who took the survey. But since they're specifically doing one field, psychology, and another field, accounting, then yeah, it's two. So it's just one sample compared, as opposed to one sample compared to every field in America.
So if it was every field in America compared to psychology, it would still be two, right?
If we threw in, if we still had psychology and accounting,
Oh, but because it's all of the, it's more of a, oh, okay, I see what you're saying.
because if you remember, if it was, I can't remember if it was sigma or what, but one of the really messy um, equations we were given,
Yeah.
and I know this was two sample because I had to freaking solve it like 17 times. A confidence interval for two proportions, or maybe it was the p-value for two proportions.
Mhm.
One of them included, I had to write out in the Excel sheet, p hat 1, p hat 2, p hat difference, and p. So you
Yeah.
had to figure out, so they'd given you the p, so the population mean for the entire country, and
Mhm.
then you had to figure out the p hat for sample 1, the p hat for sample 2, the difference between the two p hats, and it took all four of those variables to plug into the equation to get the sigma or whatever it was we were dealing with, and that was a pain. So
Yeah.
just because they give you p doesn't mean it can't be a two sample proportion. So
Okay.
if they were to, so yeah, if they were to say just in the study, you know, the percentage of people who say they're satisfied with their career is 78%. We checked with psychologists who said that they are 87%, and then we checked with accountants who said that they were 85%. Is there a difference between accountants and psychologists? The
Mhm.
main thing is you're looking at what they're studying, and when they say, "Is there a difference between psychologists and accountants?" that lets you know is, oh, we're looking at two sample proportions.
Yeah. Okay.
Does that make sense?
Yes.
Okay, double stuffed Oreos supposed to have twice the filling. You take a sample of 55. Okay, what are you thinking on this one?
Okay, 1 second. Okay. So, um, I'm gonna say a 1 sample T confidence interval.
Why are you thinking that?
It doesn't say anything about them testing the non-double stuffed Oreos. It just talks about them doing the double stuffed. So that's why I think it's 1 sample.
And that's
Uh,
totally what I got.
oh,
If they would have taken double stuffed and the original Oreos, the regular Oreos, and did a sample of 55 of each, then
mhm.
yeah, it would definitely be an independent samples.
Yeah,
But they're not mentioning that. It's just saying confidence interval to compare it to the filling amount of regular Oreos. So I'm assuming there's some stats somewhere that say this is how much filling we put in our regular Oreos, and they're putting that to the test. So
yeah.
one sample is perfect.
I know I had to reread it. I was like, why are they not doing? How to make sure they? Yeah,
No, and that's good that you're able to parse that information and figure out exactly what it is they're asking.
yeah,
Because that's like, that's what I've been telling Aaron, because doesn't have to deal with it too much. But the fifth grader that I'm tutoring,
mhm.
we've been working on story problems, and he's got math down pat. Like
Yeah,
he's doing things in his head that I'm like, holy crap, that's surprising. Like I've gotten to the point where I'm like, I need you to show me your work. You're just too fast.
yeah.
And if you're not showing me your work, we don't know where you mess up. So make
Uh-huh.
sure you're writing it out. So he's
Yeah,
got the math down. He's just having so much trouble reading a sentence in English and
mhm.
translating that into an equation. And
Yeah. Yeah,
and the fact is, that was a tricky question. Eight was tricky. The fact is, they totally made it sound like, oh, let's compare double stuff to your original Oreos, which they did, but they never took a sample of the original, which
yeah.
means that we're stuck with a one sample. So
I
that means,
definitely, yeah, I had to read it twice because I was like, why are they not doing the other
yeah,
regular stuff? But
no, but the fact that you're able to catch, they only took one sample. There's no way that this can be two sample paired or independent because they only took one sample. So
yeah.
the fact that you're able to glean that from the reading shows that you're able to translate English into stats, which I can tell you, it doesn't matter your age. That's like trying to translate English into math for a fifth grader. Stats is just a pain.
Yeah, that's funny. Uh, all right, number 9. The probability of a type 1 error.
So the type 1 error
Is
is,
alpha.
yes, and it's reflected by our level of significance, which is
Yes.
alpha,
Yes.
but that's not the definition of alpha.
Oh, poop. Okay.
So,
I
because
automatically saw like levels and okay, I was like type 1 error. All right.
yeah,
Okay.
and that's the thing is that the definition of a type 1 error
Uh-huh.
is alpha. That's what the definition of it is. But the thing is, the definition of alpha isn't a type 1 error. So it's weird. It's not a two-way street.
Okay.
So you can define a type 1 error that way, but you can't define level of significance that way.
Okay. So level of significance, the probability of sorry.
Oh wait, no. I'm so sorry. You're completely right.
You
I was
sure?
yes, I was looking at the first answer. The probability of observing a sample statistic more extreme than the one we actually obtained, assuming the null hypothesis is true. Do you know what that is?
That would be. I mean, that looks super familiar.
What do we compare to alpha?
The what do we compare to it?
Yeah.
Um,
When we're choosing
oh,
to get
p-value, p-value.
exactly.
Oh, and that's what this is. Okay.
Yes. So if if our p-value, if the probability of observing this sample statistic is more extreme than whatever value we get, assuming the null hypothesis is true, if that is less than making the probability, than making a type 1 error, then we accept it and reject the null hypothesis.
Okay.
So forget what I said. Alpha, alpha, there's two definitions. I was expecting to see the other one.
Mm-hmm.
Significance is the probability of a type 1 error. Oh no, this is where this is where I got confused. Erase, like move backwards like 3 minutes, okay?
Okay.
Okay. So the probability of observing a sample statistic more extreme than the actual one obtained, assuming the null hypothesis is true, is the p-value.
Yes.
So we want a low p-value because everything is assuming the null hypothesis is true. So if we have a low p-value that says the chances of this occurring while the null hypothesis is true is so ridiculously low that we just want to reject the null hypothesis,
Yeah.
right?
Yes.
Okay. So the probability of a type 1 error is our level of significance, is alpha. So
Yeah.
basically, we say that the probability of making a type 1 error, we usually have it either at 10%, 5%, or 1%. So 0.1, 0.05, or 0.01.
Mm-hmm.
If our p-value is less than the probability of making a type 1 error, we
Mm-hmm.
say that it's worth the risk. We're assuming that the value we got is correct, right?
Yes.
So what I was thinking of, and let me know if this is ringing a bell in your mind and if you know what word this definition goes to. But I was thinking of um so the probability that if we were to repeat this test an infinite amount of times, we
Mm-hmm.
would be correct. Uh, this percentage of the test would be correct.
Uh,
Do you know what
law of large numbers, or is it the um central limit theorem?
so you're thinking about individual samples. I'm talking about doing the experiment over and over again from
Yeah.
scratch. So if we were to do the experiment over and over again,
Mm-hmm.
we are blank that it would be correct. This 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 many. Okay, so I can't think of a way to phrase it because my brain is dead and I already like
So like
confused too. But
the more times you do the test, the more accurate it's going to be, or the closer it is going to be to the population.
that
The more,
is that is part of the central limit theorem.
yes.
What I'm thinking of is confidence. And so when we say that we are 95% confident,
Hmm.
what we're saying is we can't say that we're 95% confident, meaning uh, there's a 95% chance that this is right. That's not the way probability works.
Yeah.
So we say that we're 95% confident. We are saying that if we were to repeat this experiment an infinite amount of times, 95% of those experiments would be correct.
Okay,
Since
yes.
since we're talking about theoretical, because our confidence interval, I mean, not our confidence interval, but our level of confidence is identical to our significance level, alpha. That's why I got confused on this. So significance level is going to be the probability of making a type 1 error. So alpha equals 0.5, which means that we are 95% confident. And confidence means what I just explained. So that's why I got confused on question 9.
Okay.
Does that clear things up, or are you even more confused now about?
So it's the probability of a type 1 error then, right?
Yes. So the
Okay.
first one is p-value.
Yes.
The second one is significance level or alpha,
Hmm.
and then confidence, which is not on here, is what I got confused with.
Okay.
And confidence is stating we can't say that's, this experiment, there's a 95% chance that this experiment is correct because the experiment has already been done. The probability of it being correct is either 0 or 1.
Yeah.
So confidence is saying that if we were to repeat this an infinite amount of times, 95% of those theoretical experiments would be correct.
Yes. Okay.
So that's what confidence is.
Okay. Yeah, that makes sense.
And I have a bad habit of tying probability. I have a bad habit of tying alpha to confidence because they're inverse to each other.
Mm-hmm.
If we have an alpha of 0.5, then we have
Yeah.
a confidence of
95.
95%.
Yeah.
That's why I got confused here.
Okay.
So you were completely right with your first answer before I drove the conversation off a cliff. So,
Good.
but are you feeling comfortable? But you're feeling comfortable with your answer, right?
Yes.
Perfect. Okay, I was afraid that like I just totally drove off the rails, and then you're just like, "Oh, I've lost all confidence in my ability to statistic. Thank you for ruining my test."
You're good.
Okay.
That's funny. And 10 is actually what we just talked about. So it'd be the probability of, of observing a sample statistic more extreme.
Okay. And then that actually raises an interesting question of so the probability of a type 1 error, what is a type 1 error?
Oh, I know this. Okay, so it's an innocent is put in jail. So the right hypothesis is rejected, right? It's been a while since I've looked over that.
So type 1, if you remember, yeah, so when we're dealing with the law, the null hypothesis is you are innocent until proven guilty.
Yes.
If you are innocent until proven guilty, so you're innocent until proven guilty,
Mm-hmm.
the only way you go to prison is if you reject the null hypothesis. So you reject the null hypothesis, you go to prison.
Mm-hmm.
If the jury rejects the null hypothesis and you are innocent, that's a type 1 error. Is that ringing a bell?
Yes.
So knowing that, what is a type 2 error?
When you let go, um, when you let a criminal go.
Okay,
So,
perfect.
yeah.
So looking at this, so looking back at question 9, the probability of a type 1 error, and then answer 3, the probability of rejecting the null hypothesis.
Mhm.
Why isn't it number 3?
Um, because mm, so are we referring to the p-value? Like, why isn't p-value the probability of rejecting the null?
So the probability of a type 1 error is rejecting the null hypothesis
Yeah.
and sending an innocent man to prison.
Yes.
How does that analogy differ from answer number 3?
Uh, uh,
Because this is actually a good question, because something like this may pop up on the test.
okay. So your number 3 is the probability of rejecting the null or the probability of observing a simple test statistic.
The probability of rejecting the null.
Okay. Okay, so let me think about this. Um, so probability of rejecting the null, whether it's true or not, is they are kind of the same thing, aren't they?
Yeah, so we got to figure out how to distinguish this.
Yeah, I mean, because that is type 1 error is probability of rejecting the null.
So here's a question. Let's break this up.
Okay.
This is what I've had to do in my computer science class when we see an or. And to break this up, the probability of rejecting the null hypothesis when the null hypothesis is true. So a man is innocent. Okay, so rejecting the null hypothesis, the null is a person is innocent. We reject the null hypothesis, he's guilty. But the null hypothesis is true, which means he's innocent, which means we just sent an innocent man to jail. That's a type 1 error, right?
Yes.
Okay, how about the probability of rejecting the null hypothesis, so a man is innocent, when it's not true? So it turns out the truth is he was guilty, but we rejected the null hypothesis and said he was guilty. There's no error that happens there. That's actually the way it should go.
Okay.
So
Yes.
keep that in mind, because you'll probably see that on the test because it popped up in both questions 9 and 10.
Okay.
Probability of a type 1 error is the probability of rejecting the null hypothesis when the null hypothesis is true. If you reject the null hypothesis when it is not true, that's what you want.
Yes.
Conversely, talking about the probability of rejecting the null hypothesis when it is true is regarded as a type 1 error. What is a type 2 error in those words?
A type 2 error is when you fail to reject the null. Okay, when you let a criminal go. So when you fail to reject the null when the null is true.
Oh, close.
Oh, dang it. Okay, so it's when you let a criminal go. So
the null of any criminal, whether he's innocent or not, is going to be the null is that he's innocent, correct?
yes.
So if you let a guilty man go, that means you are rejecting the null hypothesis. No, you are failing to reject the null hypothesis.
Yes.
But the null hypothesis, him being innocent, is false.
Yes.
So is that making sense?
So when we fail to reject the null when the null is false.
Yes. So we fail to reject it. In other words, we accept the null hypothesis. He's innocent, but the null hypothesis was false. He totally got away with murder.
Yes. Okay.
Okay. So just keep those in mind, because there's different ways to ask those. There's different ways to ask the vocab,
Yeah.
just in different ways. So just make sure you understand those, because probability of type 1 error is alpha. The probability, so rejecting a null hypothesis when it's true is a type 1 error, which is equal to alpha. But only when the null hypothesis is true. The type 2 error is failing to reject the null hypothesis when the null hypothesis is true. So just make sure you understand all the different ways to define a type 1 and a type 2 error.
Okay.
And since that is kind of hard to wrap your head around, that's something I would recommend just writing down on your page of notes.
Yeah. I have a little thing. I know I've been adding to all my notes tonight. Okay, cool. So number 11.
Create a 95% confidence interval and get 10 to 20. We are 95% confident that the true mean is between 10 and 20. What exactly does this mean? So we talked about this a little before when I got really confused on question 9.
Yes. So 95% of the sample means are between 10 and 20. 95% of the data.
So here's a question. Do we care about sample means?
Nope.
Yeah, we can take sample means. We can measure sample means. We know exactly what sample means are. We don't need to estimate them.
Okay. Okay, yeah. So it's there is a 95% chance.
Oh, this is where
And you
vocab
don't
comes
use
in.
the word chance though, right?
Yeah, you don't want to use the word chance in
You never use
statistics.
the word chance, so it's 95%. I don't know. 95% of
Well, let's just go process of elimination.
okay.
Number one, 90%, 95% of the sample means are between 10 and 20. But we
Yeah.
don't care what the sample means are because we can measure sample means. We don't have to
Yes.
estimate the sample mean. There's a
Yes.
95% chance that the true mean, so the population mean, is between 10 and 20. That's a great thing to know. If we could say that the entire population, we don't know um, if it's 10, 11, or any number between 10 and 20. We don't know which number it is. We just know that it's a positive between 10 and 20.
Mm-hmm.
That's a good thing to know. But the thing is, with stats, we never talk about a 95% chance because
Yes.
once we've done our study, we have a confidence interval, and the chance that the true mean is between 10 and 20. What is the chance that the true mean is between 10 and 20 after our study's done?
Our p-value?
It is yes or no. So
Oh.
0 or 1. So the chance that the true mean is between 10 and 20,
Mm-hmm.
simply 0 or 1. The experiment is done and the true mean exists. So it's
Mm-hmm.
either going to fit between 10 and 20 or it's not. So it's either yes or no, it's either 0 or 1. That's why we don't talk about chances in stats.
Okay.
95% of the data is between 10 and 20. Um, that doesn't even make sense. Like, there's something that's kind of related to that. If, let's say, going back to box plots, we
Mm-hmm.
can say 50%, we can say 25% or 50% or 75% of the data is between these two numbers. But
Yeah.
that's box plots. That's not confidence interval.
Yeah.
So that leaves us with the last one. 95% of all 95% confidence intervals actually contain the true mean.
Yeah.
And that's what I was saying is that if we were to do this experiment an infinite amount of times, 95% of those theoretical studies
Mm-hmm.
will be correct.
Yes.
So those studies haven't occurred yet, so we can still use percentages on, we can still use chance on them. But as soon
Okay.
as the study occurs, it's either yes or no. But we're saying we are 95% of all of the 95% confidence intervals, all of those hypothetical, theoretical confidence intervals that we could create over the years will have the true mean.
Mm-hmm.
So it's a very semantic way of just saying, yeah, the probability of us being right is 95%. But the thing is, once the experiment's done, it's either yes or no. It's either you are right or you're wrong. So
Yeah.
there's no chance into it. But if we were to repeat this experiment, the next experiment we did has a
Mm-hmm.
95% chance of being correct. And if we were to do this experiment over and over and over again and follow the exact same steps that we did,
Mm-hmm.
all of those tests would have a 95% chance of being correct.
Okay. Yeah, that makes sense. Okay.
This one's definition, you should know. Question 12.
Um, is it 30.3?
Close. Yes.
Okay.
Because by definition, if you remember dealing with that app a few months ago,
Yeah.
the mean distribution is equal to the is equal. Let me rephrase this. The mean distribution of the sample proportions, which is why we like to shorten it down to x bar.
Yeah.
So the mean of the distributions of x bar is equal to the population mean. And it's there, but the thing is, any individual sample that we take and discover the mean, there's a chance that it's going to be off. So that's
Mhm.
why we take a lot of samples and then take the average of that. And if you remember, it doesn't take too many samples. It takes like 15, 20 samples. And once we take 15 or 20 samples, provided the samples are large, like 10 or larger or something,
Mhm.
then all it takes is, yeah, like 10, 15 samples. And then we average that out. And it's always, always super close to the true population mean. Do you remember that?
Yes.
So what this is saying is the mean of the distribution of sample proportions. So this is saying the mean, assume we have taken an infinite amount of sample proportions and we have taken the mean of that. So we've averaged that out.
Mhm.
That mean is going to be equal exactly to the population mean. So that one's just like straight up definition. That's one that you should just, no calculation, you should just know off the top of your head.
Know it. Okay. Then the standard deviation.
Standard deviation. I don't have the proportion standard deviation memorized yet because it's such a pain. Standard deviation. Okay. Pull this up real quick. Okay, let me know when you got the answer.
Okay. Okay. Is it 0.0458?
Yes, that's exactly what I got.
Okay. And what is the problem? So do we put it in the applet for this one? For 14?
I'm trying to. We will eventually. So we have. Oh, stupid me. Okay, so we have a z-score
Yes.
that we need to calculate. And the z-score is just going to be equal to our mean minus the population mean, which would be 0.25 in this case, because we are saying, so basically what this is saying, if you're looking at question 14, What is the probability that a random sample of 100 adults will have a sample proportion less than 0.25? That means our null hypothesis is p is equal to 0.25.
Mhm.
And, well, no, because p is 0. Yeah. So our null hypothesis is p is equal to 0.25. Our alternate hypothesis is p will be less than
Yeah.
0.25. So that means we're using 0.25 as our p. And knowing that, then we can figure out what our z is. Is you just minus your mean from the population mean, and then divide that by the standard deviation, which we got.
So did you get 1.155?
Hold on a second. Oops. Okay. So this one is the probability. I have too many tabs open. Okay. I got a ridiculously small number. What was the z-score that you got?
So for my z-score, I got 1.155, and then for my p-value, I got 0.876. But
Oh, no, I was being an idiot. I used the standard deviation as our mean as opposed to 0.3.
oh, oops.
Yeah. So I was like, I got a t-score. Yeah, I got a z-score of like 5 point something, 5.41, and then give me a tiny thing. Okay. The standard deviation. I got negative 1.091.
Okay.
And I'm
Um,
trying to figure out, because this was kind of weird. Okay.
so I think it's because, so I'm using the Excel, um, and I put in for, I'm trying to figure out what to put in for the null hypothesis.
Yeah, and that's what I'm trying to figure out too, because the equation for finding the z-score is sample mean minus the population mean over the standard deviation.
Mhm.
But I'm trying to figure out, because they give us, assume the unknown population proportion or percentage of the people in town who invest in the stock market is 0.3. And so our null hypothesis is equal to 0.3, but then our alternate hypothesis would be less than 0.25, but we always do less than, like that just confuses me. So I'm checking. So you got positive 1.09, right?
Okay, wait, I just changed it. So when I put the null hypothesis as 0.25, which obviously that's the alternate hypothesis. For the z-score, I got 1.155, and the p-value is 0.876. But I change it to 0.3. The z-score is 0, and the p-value is 0.5.
this is weird. I'm looking on the chapter and the z-score. Oh, sorry. Is p hat minus p over the standard deviation. We already have standard deviation. And so the question is, which number do we use for p hat and which number do we use for p? Because it says, assume the unknown population portion or the percentage of the people in town who invest in the stock markets, p is equal to 0.3. So if p is equal to 0.3, I have to assume that this new number we're giving us, the sample proportion is less than 0.25. I'm assuming that's our p hat. So we should go p hat minus p, p hat minus p, so 0.25 minus 0.3 over standard deviation. Does that make sense?
Yes.
Okay. And is that the calculation you did?
I just put it into Excel, so I haven't been.
Oh, you little cheater.
I know.
Dude, if I get you a good grade on this test, do it.
Yeah.
Okay, so what was it that you got again?
So, well, that's what I'm. So, when I put the null hypothesis as 0.3, I get a z-score of 0 and a p value of 0.5.
P-value. Oh, yeah, if you had a z-score of 0, that means you're looking at the middle of the graph. So that makes sense that everything to the left of your z-score is going to be 50% of the data.
Mm-hmm.
So I'm going to check the one proportion input. So we don't have an x or an n. We're just given straight up proportions. Null hypothesis is 0.3. I'm going to try this. 0.3, we want less than. And since it's asking for an x and an n, let's say 25 over 100, so that would give us 0.25. Null hypothesis is 0.3. E hat becomes 0.25, which is what I was thinking. That gives me a z-score of negative 1.091 and a value p-value of 0.138, which is what I calculated. So, screen share with me real quick, just so I can see your Excel sheet.
Yes. Let me find. There we go. Okay, so this is. Can you see?
Not yet.
Oh, you can't?
Nope. Oh, wait. Okay, there we go.
Oh, okay. This is what I have.
Okay, full screen that.
And so I did type of test less than null 3
Okay.
one
Yeah,
proportion.
what you should have done, and you're super close. This
Uh-huh.
is what I was trying to figure out the last little minute. So
Uh-huh.
confidence interval 0.95, null hypothesis is 0.3, less than. You should just change x to 25, because then that will give you a p-hat of 0.25.
Dang.
Yeah, then that changes your p-hat to 0.25, and then that should give you all the right info.
Yep. Okay. Dang it. Okay. I'm glad we figured that out because, yeah. Okay, so just change X. Okay. Okay, so let's see, what is this asking for again? What is it probably? Okay, so it's going to be, so answer 14 is going to be 0.138, correct?
Hold on a second. I did. Did I seriously just do that? not there. I think I may have clicked out of the quiz.
Oops.
Yeah, I know, seriously. Die. Okay. Where did that go? That's so weird. I seriously think I clicked out. Okay, well, let's open that up and start over again so we can at least take this.
It should be saved. Should be able to pick up where you left off.
Oh, you're right. I forgot about that. It doesn't count as a submission unless we hit submit.
Yeah. It
And
used to be like if you like lost internet connection or whatever, like that was it. But
yeah, and that's what I'm used to.
yeah.
Okay, perfect then.
Did you get
You
it
can,
open?
hey, not start. I was worried about that. I was like, oh no.
Yeah, no, they changed it so you can like literally start the quiz, exit out, and then start where you left off. It's really nice.
Oh, that's nice about Sister Cook giving us 4 hours to take the test.
I know, right?
Because last time I was in a hotel room, so I just busted it out. But for our first test, is literally I took it, I went through the entire thing, and then I took a break, grabbed some lunch, listened to some nice Enya type music on Pandora to calm me down,
Yep.
and then I went back to the test and looked over it again.
Yeah. Yeah, no, it's really nice that there's a 4 hour limit. Don't feel rushed. I hate time tests, to be honest. I
Oh
just
my gosh, yeah, my computer science class was an hour with 40 questions, and they were tough questions, and so like I was blitzing just to get through it. I didn't have a chance to go back over my answers.
like the whole time I'm thinking about the time I have left and I'm not thinking about the question. So it's just like, what's the freaking point, you know? I don't know.
Okay, so p-value, the probability of your random sample is 0.138, right?
Yes.
Okay. This is a freaking long one, but it makes sense because it's a test review. Okay. Acupril, which is a real drug, meant to control hypertension.
Okay.
Acupril, quinapril. Didn't see it too much. Okay. So I'm gonna just because we have so much of this quiz left, I'm gonna join you on the Excel sheet. I'm just gonna start plugging numbers in. So
Oh yeah.
just let me know two samples the test for proportions. So I'm just gonna start plugging things in. The control
More
group.
power to you for being able to have patience with the
Well,
formulas.
my brother and I have to go watch The Incredibles soon because he has tomorrow off. So we can
Oh,
finally, yeah. And the theaters are only $5 here on Tuesdays. So we're like, yeah, let's go watch it in a big luxury seat and 3D for only $5 because
thank
you
you.
don't have to wake up early tomorrow.
Super
Okay,
nice.
so experimental group and the control group. P1 is. Wait. Okay. Not taking Acupril. Okay. Okay, that looks much better. Type of test. Let's figure that out. Okay, so what is the margin of error on this thing?
So we do the upper bound, which I got 0.0055 minus the point estimate, which is
Oh,
P.
hold on. You're doing the confidence interval. So it's asking for the margin of error. How do we do the margin of error with this sheet? Do you know?
Don't we do the upper the higher side of the confidence interval minus the point estimate? Or
I'm trying to think with the type 1.
oh, we could do the largest minus the smallest divided by 2.
There we go. That's what I was, shooting for. I was like, where is the... Yeah, I was trying to figure out where the point estimate was here. But yeah, so we can just go...
I got the same. That's weird. For my confidence interval, I got the same number.
Wait, you got the same number as what?
Here, let me show you. So these two numbers are the same.
Wait, which two numbers?
These ones on the confidence interval.
So the standard deviation of the confidence interval and the standard deviation of the hypothesis test. Oh, that's the problem.
Is it these?
Yes, our group that took a placebo is smaller than the guys who took Acupril. So 15 should be over 579, not 1563.
Oh, wait. What? Okay. Oh. Why do they gotta word it all weird? Okay. So okay, that makes way more sense. I was like, I know I did something wrong. These numbers are not supposed to look the same. Okay, so I got 0.88 or 0.0082 and a 0.009. Is that what you got?
Wait. Okay. So question 18, margin of error. I'm doing margin of error via the confidence interval divided by 2, right? Is that how you're
Yeah.
doing it?
Yeah, so it's gonna be 0.009 minus 0.0082 equals divided by 2.
That's weird. Pull your
Wait.
sheet up again. Because I got the upper bound I got was negative 0.98 and the lower bound was negative 0.315.
Okay.
Okay, so we're looking at 61. Oops. Okay, so 61 over 15, 63, 15 over 5. That's weird.
Isn't that what it should be?
So confidence interval 95, type of test B1 less than. Hold on a second. So it should be. So it should be P1 is not equal to P2, but that shouldn't really change anything. Look at this again.
Yeah, that didn't change it.
Okay. Start at the top again. So just start with x1 and just put these numbers in and just go down.
Okay.
So starting with x1, put in 61.
Okay.
Then 1563.
Okay.
And then 15. Oh, this one is probably on me. I'm an idiot.
This one.
And 2, I put in frickin' 61. So I put in the people who got dizzy taking Acupril as the total amount of people who got the placebo, which should be 579.
Okay.
So that was my fault. Stupid. That's why I don't use the Excel.
Oh.
Okay, so confidence interval, we've got the lower bound is negative 0.003. I've got an upper bound of 0.029. Is that what you got?
No. So I got an upper bound of 0.009 and a lower bound of 0.0082.
Oh, wait. Oops. Do full screen your Excel because it looks like we got the same answers.
Oh.
So down at the bottom, confidence interval for P1 minus P2, negative 0.003 and 0.029. That's totally what I got.
Oh, I've been looking at this. Oh man. Oh shoot. I've been looking at these two numbers.
Mhm.
Oh dang. Okay.
Okay, so we got the confidence interval. We just minus 0.029 minus negative 0.03 divide by 2, and that will give us the margin of error, which is question number 15.
So negative 0.016.
I got positive 0.016. So that would just
Oh.
mean
Yeah, no, that
you
was
just
my
got the
bad.
numbers mixed up.
I did the smallest minus the largest.
Yeah.
Man, I'm just struggling. Okay, so you got 0.016.
0.016. Then question 16 is negative 0.003. And then question 17 is 0.029. So are we on the same page for that?
Yeah. So upper is 0.029. Okay. Yep. Cool.
Okay. And they're just checking to see, let's see. So the study is, yeah, I don't care. Okay. So Acupil, side effects, control group, 15 side effects. Let P1 be the true proportion and experience dizziness while taking Acupil. Experience dizziness. Do not take Acupil. So normally you'd want to check to see if P1 is less than P2. But as far as I can tell reading it, it looks like they're just checking to see if they're not equal. Are you getting anything that's saying that says that the type of test should be P1 is less than P2 as opposed to P1 not equal to P2?
Let's see. No, it seems like just not equal to.
Okay, then I've got that as my answer for question 18.
The 19, the value of your test statistic.
I got 1.458. Is that what you got?
Yes.
Okay, and the p-value?
Um, 0.145.
That's what I got. Perfect. Okay. Question 21. The true proportion of people who experience dizziness while taking Acupro is different. So it is different. It's not less than.
Okay.
Okay. And our p-value is high. It's 0.14. So we do not reject the null hypothesis. So no, I failed to reject the null.
Yes. Yeah, what's up? I'm on with my group. I don't know. I know the one you just got. I know which one you're talking about. I haven't seen it. I haven't seen it in a while. Sorry. Mama. Okay.
So we use information for the next 4 questions. A survey conducted of 1279 randomly selected adults. They're asked, are you a morning or night person? There's the hypothesis. The results are given. Conduct a test of independence. So what are we going to be using here if we're checking for independence?
T-test? Or independent sample?
No. Do you remember how we measure independence?
We measure independence by...
Think about pirates and global warming.
Oh. Chi-square.
Yes, exactly. Okay. So that's the sheet that you'll want to pull up.
Okay.
Okay. So I've got the questions to 20 up to 25. Are you that far yet?
No, I'm still plugging in the numbers.
Okay,
Sorry.
no problem.
Okay.
So we'll just go through them one by one as you get them. So question 22. Let me know when you have the test statistic and I'll double check with you.
So it's going to be 6.579.
That's what I got.
And
The p-value.
p-value is going to be 0.087.
What I got. So should you reject the null hypothesis or not?
So we're going to fail to reject the null.
And this one has a Y, so you have to give your reasoning.
The p-value is greater than 0.05.
Exactly.
Okay.
The next question is just pretty much that again, but
we have insufficient.
So yeah, so we have insufficient evidence. That's what not rejecting, failing to reject the null hypothesis means we have insufficient evidence.
Yes.
We have insufficient evidence to say what?
That, I gotta find out what the null hypothesis was. Being a morning person or evening person is independent of age. So we have insufficient evidence to say that being a morning or evening person is independent of age.
Perfect. Okay. Following for the next 8 questions, a recent book noted that 20% of investment managers outperformed the Dow Jones over a 5-year period. Okay. So this one, we have a P of 20%, so a P of 2.2. Then we have a P hat of what? 50 over 20. So that would be, wait. Oh, 0.25. So we're dealing with proportions. I'm not seeing a second sample, so it looks like this would just be a 1 proportion. Is that what you're getting?
Yeah.
Okay. So 25 over 200. Confidence interval 95%. The null hypothesis is 0.2. Okay. Lower bound 0.0. Okay, let me know when
So
you're ready to input 26 and 27.
so 0.079.
Okay, that's what I got.
For bound is 0.171.
That's what I got. Perfect. Okay.
Oof. Okay.
Suppose you've been in charge of designing the study. What sample size would you need to construct a margin error of 2% with a 95% confidence? Used prior estimate of P. Okay.
Trying to remember how to do this. I know we've done it in the past.
I'm trying to think if there's a way to cheat and use the the Excel sheet on it.
Yeah, you're right.
But I was like, oh, we can just change the margin of error to 2% by changing the confidence interval. But changing the confidence interval is not going to change our n for us. So, yeah, we'll have to calculate this one out. Okay.
I mean, I guess we could like experiment and just type in a whole bunch of different ends.
I got the equation right here. I just found it.
So what is it?
So if we know P star, which they give us, nice, which is nice, they said use 0.2 as P star. If we have P star, then N is going to be equal to our Z score, which we have on the Excel sheet, divided by margin of error, which we're going to have to calculate by minusing the confidence interval and dividing by 2, times P star times 1 minus P star.
Sorry, times P star. Then what was the next step?
P star times 1 minus P star.
X. Okay.
That's not good. We're going to mess up on the equation. Try that again. What am I doing here? Okay. And M. Oh, problem. Okay.
Sorry, it's taking me a second.
Oh, you're good.
Okay, I got 47.
47. Okay. I got 536. There's a bit of a discrepancy.
So here's what I put in. So I put -1.021 over 0.0595. And then I did that by 2. Is that
Like, so you did 0.171 minus 0.079 divided by 2?
no. So I did in parentheses I did -1.021 divided by 0.0595, and then I closed the parentheses and did that by 2 times that.
Where are these numbers coming from?
So the negative 1 point, yeah, so I did my z-score divided by my margin of error, and so I divided those two by each other, and so for my margin of error I got 0.0595.
Okay, my margin of error, I got 0.0458.
Okay.
So how did you get your margin of error?
I thought I just did 0.226 minus 0.107 equals divided by 2. So I still got 0.0595.
Where are you getting the 0.226 and stuff?
0.226. That's the confidence interval.
But we just put it in as the lower bound is equal to 0.079 and the upper bound is 0.171. That's
Oh.
what we agreed to, right?
Oh. Okay, so for your confidence interval, you have 0.226 and 0.107, right?
No, my confidence interval is lower 0.079, upper 0.171.
Okay. Am I looking at the right thing?
No, I'm looking at the wrong thing. I'm a freaking idiot.
I feel like we
Okay.
just keep making mistakes today.
I forgot to change the 25 from the last problem, so I've been doing 25 divided by 200 instead of 50 divided by 200. So I just got 50 divided by 200 with a null hypothesis of 0.2. So I've got a p hat of 0.25, null hypothesis of 0.2, a lower bound of 0.19, and an upper bound of 0.31.
Okay, so
Are we in the same area now?
um no.
Okay,
Maybe.
what does your Excel sheet look like? Put
uh,
that to the front of your computer. Let's check that out.
oh, we're screen sharing. Um, so this is what I have.
Okay, so you made the same mistake as me, or have you updated this one for our new problems?
I kind of thought I did.
Okay, the null hypothesis is zero point 0.2, so you want to change x to 50 and n to 200.
Okay.
And then confidence interval is still off. What do we have that's different? The null hypothesis is 0.2, 15. That's weird. 50 divided by 200. Why is your p hat 0.3?
Hmm.
Okay, so put your mouse over by p hat. Now move over left one to the end. And then go down and manually change that to 200. See if that fixes it. Because that's weird that it didn't update to 200 when you changed that.
Yeah.
Okay, there we go. P hat is now 0.25. Confidence interval is 1.9 to 1, 0.2. Okay, perfect.
Okay.
There we
Well,
go.
we'll
Okay,
do.
so that means we have a confidence interval of 0.19 to 0.31. That's our confidence interval, giving us a margin of error is going to be 0.31 minus 1.19 divided by 2, which
0.06.
0.06. And then if we do the equation, so that big ugly thing, so we're going to do, I got a z-score of 1.768. Is that what you got?
Yes.
Okay, so we go 1.768 divided by 0.06, square that,
Uh-huh.
times that by zero point 0.2, times that by zero point 0.8. And I got an N of 139.
Okay, give me 1 second. Did you get 139? Is that what you said?
Yes.
Okay, that's what I got.
Okay, finally
Whew.
on the same page. Okay, so which of the following pairs of hypothesis is the most appropriate? Well, we believe that p is equal to 0 is equal to 0.2. We want to see if the top 10 business programs perform better. So Null, p is equal to 0.2. Alternate, p is greater than 0.2.
Requirements must be met.
NP is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. And we got that. Value of the test statistic is 1.768, which is what we needed to solve for n. So we should both already have that.
Yes.
The p-value I got is 0.961. Oh, wait, hold on. Type of test, changing type of test from less than to greater than. My p-value is instead 0.039, which is a good p-value. So, yes, I reject the null hypothesis because the p-value is 0.039, which is less than our alpha of 0.05.
Yes.
Okay.
Ooh, look at this next one.
Oh my gosh. Next set of problems is 6, and then we have 2 more sets of problems of 6. Ugh.
How long is this one? Oh my gosh. It's like
Hold on a
50
second.
questions. It's insane. Okay.
I seriously may need to finish this up early. I can't remember what time our tickets are. So we've got the 8:20 showing. We're fine. I was afraid we had the 7 o'clock.
Okay.
Okay, so I'm good.
Okay.
Oh, that's way too big for an explanation. Okay.
I hate this question. Okay. Well, it's given us a file, an Excel file, so.
Okay, file with a bunch of stupid data. So let's see what we got. This one looks like this is going back to the beginning of the semester. We got 100 blocks of Spanish text. Each contain 300 sentences, which we don't care. We care about the 100 blocks and the scores that each one has. And the scores are given as decimals less than 1. So,
One sample t-test?
yeah. Provided I'm not seeing a what's its face? Sigma. So, yeah, t-test instead of z. One sample t-test. Drag all of this and copy paste because I want to be lazy. Okay, so the mean that they gave us was 0. Oh wait, seriously, jerk. This thing didn't even calculate it out for me, so I need to do it anyway. Okay, so this cell is going to be equal to the average of all these guys. The standard deviation. to a 100 of it. A 104.
Okay.
And then it's going to be 4.
So I got 0.282.
Okay, 0.22. That's what I got.
Oh, for my upper, and then for my lower, I got 0.293.
The upper 0.293. I got a ridiculous test score though. Okay. Calculate the degrees of freedom. Degrees of freedom is just sample size minus 1, so 99. Input the test statistic. I got a ridiculous one of negative 3,683.938.
Yes.
That is just insane.
Yeah, that is insane. You said negative 3,683, right?
Yeah.
Okay, and then 0.938. Okay. P-value. I got 1.
Yeah. That's what I got to double check to see what it is. So they're asking, okay,
Input.
these scores are recorded, but assuming or satisfied confidence interval. Or are we checking for not equal, less than, or greater than? That completely changes our p-value depending on which one we're looking at.
So this says not equal to.
Let's see.
If you look right above question 36, it says our.
Yeah, I'm an idiot. Okay.
No, you're good because I didn't change that.
Not equal, and that gives us a p-value of essentially 0.
Okay.
0.000. That says 4.18 to the negative 256. So there's 255 zeros before we hit that 4.
Yikes. Okay.
Based on the results of this test, what would you conclude? Significance level of 0.5.
We have sufficient evidence to say, because we're rejecting the null. What was the null? That it was equal to. So we have insufficient evidence to say that the true mean is equal to 0.295.
Say that again.
We have insufficient evidence to say that the true mean is equal to 0.295.
So what's our p-value?
Our p-value is 0.
And our alpha?
0.05.
So does that mean we have sufficient evidence or insufficient evidence?
We have insufficient evidence.
What would give us sufficient evidence then?
If our p-value, so the p-value is low, so we reject the null.
Mm-hmm.
Oh, I'm smart. We have sufficient evidence. To say that the true mean is equal to 0.295.
So we reject the null hypothesis. What's the alternate hypothesis?
Oh my gosh, I'm messing up. Okay, that it's not equal to.
And that's not an option, but what's another way of saying not equal to?
Different than. Oh
There
my
we
gosh.
go.
Yeah. Why did that?
We're both just. It's the 4th of July tomorrow,
I
and
know.
I have reading and homework that I need to do tomorrow, so I'm not even getting the day off anyway. So it's like,
Oh,
blah.
yeah. Oh, okay.
And this heat has just been getting to me. I think we've only hit like triple digits maybe twice so far this year, but just
Oof.
being in the 90s kills me.
Yeah. All right.
Okay, last set of questions.
So we have two different sets of data.
Color when they first wake up. Get this theory.
So it's a paired sample.
Yes, we were checking the heights of the kids in the morning and in the evening, so that's totally paired set. So highlight these. It doesn't look like I'm not seeing any blank values, so it looks like we don't have to delete anything.
Yeah, that's such a pain when they do that.
Double check, no zero values. Okay. This is a nice long homework assignment, Alex. What are the
Hmm.
kiddies doing? Ah, good Wednesday. She decided to stay in here with me.
Okay. I got all the stuff entered.
Okay, so
So
95%. So I've got a confidence interval of
8.728.
yep, up to 10.455. You got that?
Yep.
Okay. Statistic. I got 22.446
Yes.
and degrees of freedom of 40. Again, another horrifically low p-value. Makes me think, this makes me feel like we're gonna have to go back through and take this quiz on our own a second time before we take the test on Thursday.
Yeah, I agree.
Seriously, these p-values are low.
Oof.
Granted, with population size, I don't know. We'll see. Okay. And then based on your result, is there enough evidence to suggest children are taller in the morning? Yes, because we rejected the null hypothesis. Save, go to submit. I'm blitzing through this. And we missed a lot.
No way. How many?
So, oh, wait. Yeah, we missed that one that seemed really, really weird, 37, where we got the T score of 3000. And so we
Oh,
missed that with the associated p-value question of 0.00, which
uh-huh.
makes sense that if we missed one of those, we would miss the other.
Yeah.
This one, though, the last one with a t-score of 22 and a p-value of 0, we're totally good with. So what
Okay.
else did we miss? It says a lot, though. It says we got 38 out of 43, so that means we missed 5, and I just found 2. So let me look for the other 3. Okay. Um, Seriously? Okay, question 3. Human resources reported data. So they split the people into 2 groups: 40 years older, they also and 40 and younger. If both age were treated equally. Okay, let me think about this. Okay, so determine if age discrimination is a factor. The company reported the numbers of employees in 2 groups and over 40, and also reported the number of employees in each group who were terminated. Oh, that was stupid. Okay, have you submitted yet?
Uh-uh.
Okay, scroll up to question 3.
Okay.
Change 3 from independent sample t-test to test of 2 proportions.
Okay.
The company reported the number of employees in each group who were terminated. So we're looking at number of terminated over number in group, which is going to get
Right. Was your percentage, which means it's a proportion.
exactly, yeah. Okay, so that's 3. Um, what's the next one? There are way too many questions on this one. Okay, next one is 25. And this one's just wordy. Maybe you got it right, and I just put down the wrong one. So your conclusion, you based your results. We have insufficient evidence to say that being a morning or evening person is independent of age. Is that what you put?
We have insufficient evidence to say that being a morning or evening person is independent of age.
Okay, let me double check this.
So for p-value,
So what we did is, should you reject? No, we did not reject. So we're saying that the null stays true, and the null states being a morning or evening person is independent. So we are looking for independent. We have sufficient evidence to say being a morning person or evening person is independent of age. I guess try that one.
we have sufficient evidence.
Yeah, which is weird because usually if we are failing to reject the null,
Insufficient.
then we would say insufficient. But the thing is, question 24, should you reject the null? No, we shouldn't reject it, and we got that one correct. So that means the null is correct, and the null is stating a morning or evening person is independent of age.
Okay.
So I don't know if that's just a typo or what, because that's the only difference I can see between those 2 answers. But you
Yeah.
got that one, Shane?
Yeah.
Okay, and then one final one. Ah, we missed 28, which was the N.
Oh,
That one
that
was
was hard.
such a pain to calculate.
Hmm.
Okay, let me look at that one again real quick. Okay, so margin of error. Oh, wait, am I really that dumb? Ah, okay, this is what we did wrong. That's stupid. Remember how we calculated the margin of error by taking our confidence interval, subtracting it, and dividing it by 2?
Yeah.
It said,
It
what's
says
this
it's 2%.
if it's 2%? So let me just change that to 0.02. Okay, I changed that one to an N of 5,000, which sounds like a lot, but the thing is, when your margin of error is 0.02, you need a lot of people.
Yeah.
Okay, so change that one. Actually, change that again. I
Okay.
accidentally changed the confidence interval, not the margin of error. So with a margin of error of 0.02, our n becomes 1,250.
Okay.
Okay, so you got that for question 28?
Yes.
Okay. And then going back down to the last two that we missed, I'm like so tired. I'm just like, I don't even want to bother with it. Okay, so this one was the blue score. Okay, which we decided was just a simple t-test. So let's pull that one up.
Is it the last two questions we got wrong?
Not the last two, it was that second to last set of questions. So
Oh, I see.
37 and 38.
Okay.
Okay, so we've got.
This one was easy. I thought it was.
Oh, I think I see what it did. Okay, that's why it looks so weird. So this is why I don't like Excel. I like doing it by hand because I have to do every single step. Anyway,
Yeah.
okay. So level of confidence is 95. Null hypothesis is 0.295. My sheet says 10 and I didn't change that. So that's why that one was so freaking off, was because we were comparing a sample mean of 0.28 to a mu of 10. That's a
Mm,
huge difference.
yeah.
Let's change 10 to 0.2. Why is it not letting me change that? Don't be dumb.
So our test statistic would be negative 2.803.
Ah, excuse me. Okay, so T score negative 2.803. That's what you got?
Yes.
Okay, and that gives us, that's obviously not going to change degrees of freedom, but that does change the p value to 0.006.
Yes.
So that's still smaller than 0.05, so that doesn't change question 39. It just meant that we got question 37 and 38 wrong. So have you got those ones updated?
Yes.
Okay, so if those are updated, submit your answers. Let's see what we get.
We still got three wrong.
What?
Okay, let's see. Um,
So which ones are wrong?
okay, so question 27 and 28 are still wrong.
27, 28 are still wrong.
Oh. Whoa, wait a second. That's
Wait,
weird.
I didn't get. Wait, so which ones? 20,
Maybe I typed something in wrong. Okay, because I got like,
because I got 27 right.
yeah, I got 20. What is this weird? I got 25, 26, 27, and 28 all wrong.
Okay, I got 25, 26, 27 correct. 28 I had wrong, and that was we were solving for n. So,
Okay,
so
and
we're
I
gonna
got,
okay.
that's weird. Okay, so for 28, I put 1250.
50, and that got marked as wrong.
Yes.
Ugh.
So what did you
Okay.
put for 27?
27 I got 0.31.
26, you got,
0.19.
and then 25, you did.
25 based on the results. Wait, so this one was one that I got wrong. We have insufficient evidence to say being a morning person is independent. You changed that to say we have sufficient evidence to say being a morning person is independent,
Yes.
and that's still wrong.
Yes.
Okay, that's weird. Okay, so should we reject? No, we're not rejecting. So what's the null? Being a morning person is independent of age. This is just a weird question. Okay, we have sufficient evidence to say that being a morning person or an evening person is not independent of age. Oh my gosh, did they... Okay, no, it's not independent. Being a morning person is... So the null is independent of age. By alternate hypothesis is not independent of age. And if we go through, we got everything right. Should you reject the null hypothesis? No, p-value is greater than 0.5. So we're stuck with our null. Our null states being a morning or evening person is independent. We have insufficient evidence. Dang it, now I'm seeing it. You were right. It is insufficient evidence, but the fact is we're getting rid of that. I mean, it is insufficient to state our alternate hypothesis. So it should be we have insufficient evidence to say that morning or evening person is not independent.
I hate when she does that.
Oh my gosh, there's so many negatives in there.
I know. It's just like,
So many double negatives. Okay, so switch
where's
to
my
that.
English teacher? She would be so pissed off at this right now. Too many negatives in one freaking sentence.
Okay, so 25, we have insufficient evidence, so a negative. We have insufficient evidence to say being a morning or evening person is not negative, independent, negative of age. So we've got 3 negatives in there.
Great.
Ugh. Okay, so you got that changed?
Yeah.
And you got question 26, 27, and 28. We haven't done 28, but you've done 26 and 27 updated?
Yes.
Okay, let me take one more look at 28 because I seriously just want to break. But, okay. So the equation, looking at this again, we want, what do we want? Oh, this is the 2, okay, the 1 sample z-test proportion.
Huh. I just did it again. And I got what you got. I got 1250.
And that's what you have under question 28 currently? Because I
1200,
haven't reopened the quiz yet.
1250. I
And
didn't
that's,
put any decimals though.
but if it's a whole number, you wouldn't need decimals.
Oh yeah, because it's a sample size, so it has to be a whole number. Hmm.
Let's see. Let me think. Margin of error. Okay, so a margin of error of 2%. So that is going to be z-score or z-score. Did we get the z-score right? Did it ask for that? It didn't ask for the z-score, which is a little annoying. So maybe we got that one wrong. No, it asked for the z-score. So we've got the z-score of 1.768 correct. What else goes in there? Z-score divided by margin of error. Our margin of error is 0.02.
Oh, man. Sorry, my computer's at 2%. I just realized.
Oh, no problem.
It really fast.
Okay, try this. And this is going to be annoying. This is, in my opinion, Sister Cook's been great, but I think this is an example of
Ouch.
poor writing of the question.
Okay, give me 1 second.
Okay. using? Is it? Oh, let me look at that equation.
Pretty sure we have the equation right.
So it's P star. So it's not P hat or P. It's P star, which they gave us.
Yeah.
Gave us being P star equals 0.2. So we've got P star. We've got 1 minus P star. We've got Z. So that leaves the margin of error that we may have messed up. And the margin of error he's asking for, we need to construct a margin of error of 2% with a 95% confidence interval. So that would be, let me think. I'm trying to think. So our confidence interval is actually measured in percent, I think. Because
You
it
think?
says, well, a recent book noted that only 20% of all investment managers. So when we look at everything, the lower bound 0.19, the upper bound to 0.31. Okay, never mind. So that would basically be, if we're translating that to percentage, the lower bound is 19%, the upper bound is 31%. So that means if we're doing 2%, we do want that to be 0.02, which gives 1250. Okay, so 1.768 divided by 0.02 squared times 0.8 times 0.2. I honestly can't think of what we're doing wrong there.
Yeah, maybe this is one we should ask Sister Cook about.
Yeah, probably, especially since so just double checking, you got, so scroll back up to 25. Let's go through the ones that we're pretty confident with, and then we'll hit submit and see what happens, okay?
Okay, so 25.
Should be, we have insufficient evidence to say that it is not the null hypothesis. So we have insufficient evidence to say not independent of age.
The last one, right?
Yeah, you've got that highlighted?
Yes. And then
Okay. 26 is 0.19. 27 is 0.31. Didn't you say that we only had that you only had 3 wrong?
I got, so my score was 40 out of 43, but there's 45 questions. That doesn't make sense. Did you realize that?
40 out of 43. Some of the questions are worth partial,
Oh, okay. That makes sense then.
like 27 and 28 are 0.5 each um because they're lower and upper bound.
Yeah, so
So 40, so
yeah,
if you missed
wrong.
so if you missed one, okay, so if you missed 25, that would be minus 1 point. And then missing both 26 and 27 would be a second point. And then if you missed 28, then that would be the last point. So those are the 4 that you got wrong.
Yeah, I'm entering them in right now.
Okay.
It's such a pain to have to with a long quiz.
I know this is such a long one. Okay, how's it popping up?
Sorry, I'm still entering all these stuff
Oh,
in.
no problem. Let me know if you need any of the answers.
Okay. Almost there. So, did we decide just to do 28 as 1250?
1250. Yeah. Yeah, I'll have to figure that one out later.
Okay. Getting closer. I wonder if I should just put the decimals in there, even though it's
You know, honestly, might as well give that a shot.
right,
Yeah, it doesn't make sense,
but
but
maybe.
that could just be a programming oversight.
Man, this is a long quiz. Okay. Finally, I have them all entered. Let me just put in the decimals for that one, which is point 33. Moment of truth. Okay. Yeah. So we got 32 out of 42 out of 30. Oh, blah blah blah. We only got one wrong. So
See, now you're getting just simple whole numbers.
I know I'm like
It's like the
I can't even read anymore.
it's time for bed for you.
Seriously. Yeah. So we 28. We
Okay.
got that one wrong. So
Um, tomorrow's the holiday, so I know you don't want to think about it, but I obviously don't have any plans during the day. It's all evening plans. And then Thursday, I want to take the test before midnight,
yeah.
and I'm tutoring Erin from like 10 to 11 a.m. on Thursday. But if you need kind of an emergency review session, like that's what we're here for. But actually, I like the fact that you said you go back and you kind of listen to our discussions occasionally to kind of
Oh,
clarify some things.
I
But
totally do.
but if you feel like you're going through the review, going through the homework and stuff, and something just isn't making sense conceptually, I
Yeah.
should be pretty flexible over the next few days to kind of, you know, get on and have a quick discussion that hopefully doesn't go into are we on our third hour here?
Oh,
We
we
started
passed
at
the third hour. We're
yeah,
we're
we're in
about
our third
3.5 hours
hour.
right now.
Provided you don't make me go into a third hour, I am more than happy to get on and Skype with you. I need to pay it forward. Like I said, my brother got on Hangouts for an hour and a half Friday night to walk me through my project. So I'm
Yeah.
kind of in a position where I need to pay it forward. So if you need a review tomorrow or Thursday, let me know and I
Cool.
can jump on and help you out.
As always, I appreciate your help.
Okay, no problem. And especially since, yeah, we don't even have a group meeting on Thursday because it's
Yeah.
just the test and we need to turn stuff in. So I
Yep.
won't see you until next week.
Yeah.
So definitely, if something's not making sense and you have a question, totally feel free just to hit me up and we can Skype or we can text if that's what it takes, or we'll Skype if that's what we need. Um,
Cool.
little free time without that second group, and like I said, I got to pay it forward because my brother was super nice to me last week.
Goes around, comes around, right?
Exactly. But yeah, otherwise, if I don't hear from you, I will see you next week.
Cool. See ya.
Okay, have a
Happy
good
4th of
fourth.
July.
Okay,
Bye.
bye.